ഹായ് ഫ്രണ്ട്സ്, D3 ക്വിസിലേക്ക് ഏവർക്കും സ്വാഗതം. 9ാം ക്ലാസ്സിലെ കെമിസ്ട്രിയിലുള്ള ആസിഡ്സ്, ബേസസ് ആൻഡ് സാൾട്ട്സ് എന്ന പാഠത്തിൻ്റെ നോട്ടിൻ്റെ ഫസ്റ്റ് വീഡിയോ ആണിത്. ഇതിൻ്റെ സെക്കൻഡ് പാർട്ട് ഉടനെ തന്നെ അപ്ലോഡ് ചെയ്യുന്നതായിരിക്കും. നിങ്ങൾക്ക് ഈ വീഡിയോ ഇഷ്ടമാവുകയാണെങ്കിൽ ലൈക്ക് ചെയ്യുക, ഞങ്ങളുടെ ചാനൽ സബ്സ്ക്രൈബ് ചെയ്യുക, മറ്റുള്ളവർക്കും ഇത്തരം അറിവുകൾ ലഭിക്കുന്നതിനായി ഷെയർ ചെയ്യുക. നമുക്ക് വീഡിയോയിലേക്ക് കടക്കാം. ആസിഡ്സ്, ബേസസ് ആൻഡ് സാൾട്ട്സ്. Common properties of acids. Turn blue litmus red. Liberate hydrogen on reaction with highly reactive metals like magnesium and zinc. React with carbonates to form carbon dioxide gas. Marble, eggshell, seashell or calcium carbonates. Have sour taste. Find the characteristics of the substances given in the table below using litmus papers. Substance. Change in the color of litmus. Characteristics. Vinegar, blue litmus turns red, acidic. Lime water, red litmus turns blue, alkaline. Soap solution, red litmus turns blue, alkaline. Hydrochloric acid, blue litmus turns red, acidic. Common components in acids. Name of acid, chemical formula. Hydrochloric acid, HCl. Sulphuric acid, H2S04, nitric acid, HNO3, carbonic acid, H2CO3. Hydrogen is the common component in acids. Acid dissolves in water to form oppositely charged ions. Example, HCl gives H plus Cl minus. HNO3 gives H plus NO3 minus. The common properties of acids are due to the presence of hydrogen ions H plus present in them. Acids are substances which can increase the concentration of hydrogen H plus ions in an aqueous solution. H plus ions have no independent existence, so they combine with water molecules and form hydronium ion. H3O plus. H plus H2O gives H3O plus. Acid can be classified into two: mineral acids and organic acids. Sulphuric acid, hydrochloric acid, nitric acid are examples for strong mineral acids. The natural substances with sour taste which we use in our daily lives contain organic acids in low concentration. Substances. Name of acid contained: lime juice, citric acid; curd, lactic acid; tamarind, tartaric acid; vinegar, acetic acid; tomato, oxalic acid; green apple, malic acid. Basicity of acids. The number of hydrogen ions that can be donated by one molecule of an acid is called its basicity. Monobasic acid. If the basicity of an acid is 1, it is called a monobasic acid. Example, HCl or hydrochloric acid is equal to, it gives H plus Cl minus. Dibasic acid. If basicity of an acid is 2, it is called a dibasic acid. Example, H2SO4 gives H plus HSO4 minus. HSO4 minus H plus SO4 gives H plus SO4 2 minus. H2SO4 gives 2H plus SO4 2. Tribasic acid. If the basicity of an acid is 3, it is called tribasic acid. Example, H3PO4 gives 3H plus PO4 3 minus. The compounds formed by the reaction of non-metal oxide with water are acidic in nature. Example, CO2 plus H2O gives H2CO3, that is carbonic acid. SO2 plus H2O is equal to H2SO3, and that is sulphurous acid. Acid rain. Industrial areas and townships, the chances of air pollution are very high. In such regions, gases like SO2 and NO2 reach the atmosphere in larger amounts. These gases dissolve in rainwater and reach the soil as acids. This is known as acid rain. What are the environmental problems caused by acid rain? Answer: plants lost their ability to produce carbohydrates through photosynthesis as their leaves are destroyed. Severe acid rain destroys the greenery of a region. The acidic nature of water causes the death and destruction of fish and corals. Destroy monuments, sculptures, and buildings. What measures are to be taken against the environmental issues caused by acid rain? Answer: reduce the excessive use of fossil fuel. Before using fossil fuel, remove the sulfur content from them as far as possible. Alkalis. Experiment 1. Materials required: magnesium ribbon, water, litmus paper, matchbox, spirit lamp. Procedure: burn a neatly rubbed and cleaned magnesium ribbon. Observation: a white powdered ash is obtained. 2 MgO plus O2 gives 2 MgO. Magnesium metal react with oxygen to form magnesium oxide. Take the product in the watch. Add few drops of water. Dip a red litmus paper in this. Observation: red litmus turns blue. Indicate the basic character of the substance. MgO plus H2O gives MgOH2. When magnesium is added to water, MgO, magnesium hydroxide, is formed. Experiment 2. Materials required: calcium oxide, water, red litmus paper, beaker, test tube. Procedure: take some water in a beaker, add some quicklime or calcium oxide and stir it. Take some clear solution in a test tube from the beaker and dip a red litmus paper. Observation: red litmus turns blue. Indicate the basic character of the substance. CaO plus H2O gives CaOH2. Calcium oxide reacts with water to form calcium hydroxide. MgO and CaO are basic in nature. Both are metallic oxides. Metallic oxides generally exhibit characteristics of bases. The bases that dissolve in water are called alkalis. MgO, CaO, K2O, Na2O are metallic oxides or basic oxides. Common characteristics of alkalis: have alkaline taste, turns red litmus blue, soapy to touch. Chemical names and formulas of some familiar alkalis are given in the table. Complete the table. Chemical name of alkalis. Chemical formula: sodium hydroxide NaOH, calcium hydroxide CaOH2, ammonium hydroxide NH4OH, potassium hydroxide KOH. Dissolution of sodium hydroxide in water. NaOH gives Na plus OH hydroxide ion. Ionization of calcium hydroxide. CaOH2 gives Ca2 plus OH hydroxide ion. Alkalis are substances which can increase the concentration of hydroxide OH minus ions in an aqueous solution. The common names of some alkalis, their chemical names and chemical formula are given in the table 5.4. Common name, chemical formula: caustic soda, sodium hydroxide NaOH, milk of lime, calcium hydroxide CaOH2, caustic potash, potassium hydroxide KOH. Arrhenius theory: the equations representing the ionization of some acids and alkalis are given below. Fill in the blanks. HCl gives H++ Cl minus. KOH gives K++ OH minus. H2CO3 gives 2H plus CO3 2 minus. NH4OH gives NH4 plus OH minus. HNO3 gives H plus NO3 minus. In 1887, the Swedish scientist Svante Arrhenius put forward a scientific theory regarding acids and bases. He proposed that any acid or base, when dissolved in water, dissociates into ions. According to his theory, acids are substances which liberate H plus ions in aqueous solution, and bases are substances which liberate OH minus ions in aqueous solutions. Neutralization reaction. Acid and alkali react with each other to nullify their individual properties. Such chemical reactions are called neutralization reactions. During the neutralization reaction between sodium hydroxide and dilute hydrochloric acid, the acidic and alkaline properties cancels each other and become a neutral solution. As a result, the color of phenolphthalein in the solution disappears. NaOH plus HCl gives NaCl plus H2O. Slaked lime is added to soil to decrease the acidity of soil during farming. To decrease the acidity of stomach, antacids are used. Alkalis like calcium carbonate, carbonate, aluminium hydroxide, sodium bicarbonate, and magnesium hydroxide are the main components of antacids. pH value. Determination of pH value is the scientific method for finding the acidic or alkaline nature of substances. The Danish scientist Sorensen devised the pH scale for this. The pH scale was devised based on the H plus ion concentration in the solution. Here you have to draw pH scale. The pH scale is the method used to express acidic or basic nature of a substances based on the amount of H plus ions present in their aqueous solutions. On the basis of the pH scale, the pH value of a neutral solution is 7. The pH value of acids is less than 7 and that of bases is greater than 7. The biggest values of different solutions can be found out at compared. A pH paper, pH solution or a pH meter can be used for this purpose. pH meter. The pH meter is a device used for the determination of the pH of aqueous solutions. A pH meter measures the voltage between two electrodes and convert it into its equivalent pH value. The probe is the most important part of this equipment. It is a sensor attached to the end of a rod like a portion made of glass. The pH is measured by dipping the probe in the solution. The pH of soil is an important factor for crops. It is important to identify whether the soil of a region is suitable for a particular crop. Acidic soil is suitable for some crop while basic soil for a few others. Thank you for watching. Please subscribe us.